6.5 talks about rational functions and rational inequalities. We are not going to do rational inequalities. We're going to talk about rational functions. When you hear the word rational, what do you think of? Can't hear you?
Fractions.
Fractions? Does anyone think of anything else? Anyone think of anything else? That's a question. Okay, so rational says, hey, we're dealing with fractions of some kind. But we're dealing with here a polynomial over a polynomial. Okay? So in this section, we want to learn characteristics of rational functions, vertical asymptotes, horizontal asymptotes, graphing rational functions, and we're going to not do solving rational inequalities. Okay? So, many of you who are in the co-requisite have already seen information about asymptotes. So this is what this section is introducing as well. Okay? So, now just so we talk about it a little bit informally, whenever you've graphed functions before in this class, we've mentioned asymptotes, we just haven't formally defined them. Like whenever you got a graph that gets close to something but never touches it, those are asymptotes. Okay? But now this section formally defines it. Okay? So let's start out with the definition. A rational function. A rational function is a function that can be written in the form f of x equals p of x over q of x, where p of x and q of x are polynomial functions and q of x is not equal to 0. So we've really already talked about rational functions before. Remember when we talked about f over g of x and we talked about finding the domain and everything? We've talked about this, right? So no surprise that the domain is introduced or talked about again here, even though we've already talked about it. The domain of p of x over q of x consists of all real numbers such that q of x is not equal to 0. Bless you. So the domain of the rational function p of x over q of x is the set of all real numbers such that q of x does not equal 0. Okay? Now, this arrow means approaches. So this is new notation. So make sure you're paying attention. This is new notation. This is read as x approaches c from the left-hand side. So when you see a superscript minus, that means from what side? The left. So if you have, just so you can visualize what's happening, if that's c, x is approaching c from this side. So it's getting closer and closer to c from the left. So x is approaching c from the left-hand side. How do we read this? X approaches c from the right. So you expect to see c, and values are getting closer and closer to c, but from which side? Right. Okay? And so here, this is x approaches c, but that means we're going simultaneously from the left and the right. So now, as x approaches c, that takes into consideration that we are going from the left and the right. Okay? All right, so that's new notation. So now you got this? Okay, so let's continue. The vertical line, x equals c, is a vertical asymptote. The vertical line, x equals c. It's important that you understand it is a line, so it's in the form of x equals. The vertical line, x equals c, is what we call a vertical asymptote of your function f of x. This if f of x, what does this mean? This is really two words. If f of x, read it. Good. The vertical line x equals c is a vertical asymptote of f of x if f of x approaches plus or minus infinity as x approaches c from the left or x approaches c from the right. What does this mean you're looking at? So if you're visual, pay attention here. If you have, this line would be x equals what? Good. Notice that it is a line, so we have what? We have x equals 2. A vertical line is x equals 2, not 2. It's what? X equals 2. That's important. So note that I can write this. It's getting closer, so note you have a couple of things happening. As x approaches 2 from the left, your function approaches what? Nope. As x approaches 2, well, this is the right, not the left, first of all. As x approaches 2 from the right, our function approaches what? Positive infinity. As x approaches 2 from the left, our function approaches what? So notice that you're paying attention to two things at once. X is getting closer and closer to that value where you have your vertical asymptote at x equals 2. But you're also seeing what happens to your function. It's either going to go to infinity or negative infinity. When that happens, you have a vertical asymptote. Okay? So note that, this is important, for a rational function, p of x over q of x, we have vertical asymptotes where your denominator equals 0. Whatever makes your denominator equals 0 is where you have a vertical asymptote. So make sure you note that. Okay? Now, the horizontal line, y equals c. Horizontal line is y equals c. Is a what?
Is a horizontal asymptote.
Very good. Both of you. It's a horizontal asymptote of f of x if f of x approaches c. So it's now approaching a constant instead of plus or minus infinity, and x is approaching plus or minus infinity. So notice the difference. If you have a vertical asymptote, your function is going to approach plus or minus infinity whenever your x values get closer and closer to the constant. But for a horizontal asymptote, your function is going to approach a constant as x gets larger and larger, so positive or negative. So what this looks like,
Can you record this?
it is being recorded. Been recording the whole time because that's what you all always ask me to do. What is that line?
-2. Y equals negative.
Oh, right, because it's a line. Good, it's a line. So it's y equals -2. That's your line. So notice that if I just take our function to be, let's say, this. Then notice here, that as x approaches infinity, our function gets closer and closer to what? -2. As x approaches negative infinity, our function gets closer and closer to what? -2. So notice that our function is now approaching this line, y equals -2, or it's approaching this constant, -2. Okay? The difference between the horizontal and vertical. So now it's just examples. Question? What questions do you all have? Okay. All right. So let's look at a couple examples. And so here we have, it says find the domains and the equations for the vertical asymptotes of the following functions. Vertical asymptotes are in the form what equals? No. X equals C. X equals a number. Good. Vertical asymptotes are always in the form X equals. Horizontal asymptotes are always in the form of?
X equals C.
No.
Oh, wait.
Y equals C. Okay? Horizontal asymptotes are in the form?
Y equals C.
Vertical asymptotes are in the form?
X equals C.
Remember that. Drill it in. Okay? So, we find our vertical asymptotes for a rational function by doing what?
Setting the denominator to 0.
Good. Set our denominator equal to 0. And what do we get here? What do we get?
X equals.
Oh, we get x equals -3. X equals -3. So x equals -3 is a what? Very good. It's a vertical asymptote. We were also told we need to find our what?
Domain.
Domain. Good. What is our domain?
All real.
You said all real numbers? I see a head shaking no.
Would it be negative 3?
Oh, it'll be what? Interval notation, please. Ariana, say it. You're drawing it in the air. What is it? A bracket? Say it again.
Bracket, then you put -3.
I'm wondering. Hmm? Say what? Oh, come on. It's fresh. Is it what? Parentheses?
Parentheses, negative.
Parentheses, stay focused.
Parentheses, negative infinity to -3. Right? Wait. Don't listen to me.
What? I am listening to all of you.
Close parentheses.
Close parentheses. Union. Arcas what? Union what?
Negative infinity and infinity.
Well, you gotta put bracket or.
I mean parentheses.
So you're saying,
Then another.
so no, it's not funny. You're saying we take negative infinity to -3, union negative infinity to infinity. So what you're saying visually is you take all real numbers and then you are also gonna look at if this is -3, you're gonna take this chunk as well. Is that what you're saying? Or is that what you wanna say?
But if it stop at, I mean, if it's -3, don't it stop at -3, then right?
That's my question for y'all.
Or is there another
So would it be a -3?
Would it be what?
But why would it be a union though?
That's a good question. So for this function, you said that -3 makes our denominator what? If we substitute a -3, our denominator becomes what? What does our denominator become if we substitute in -3?
0.
0. Can we divide by 0?
No.
No, that's illegal. We can't do that. So x equals -3 is a vertical asymptote. -3
It's not included.
is not included in our domain.
That's why.
All the other numbers count, right?
Mhm.
So then my question is, how do we write that in interval notation?
Negative infinity to -3 union. -3 to positive infinity.
Union -3?
Yeah.
I heard two of you say it. Does everyone confirm? You think? That is correct. That's our domain. So That's not correct. Those three are not. So again, remember, for a rational function, whenever you identify your vertical asymptotes, or asymptotes, that's where your denominator is equal to 0. That means x equals -3. So we continue to use this to help us find our domain. Our domain we get from our x values. So our x values can be any real number except -3. In interval notation, that's this. What questions do you have? What questions do you have? Okay, let's do another one then. Make sure you have it. Since no one asked questions, same instructions. F of x is equal to 2x squared plus 2x minus 4 over x squared plus 2x plus 1. What should we do? Factor, very good. So 2x squared plus 2x minus 4. How do we factor our denominator? Say what?
X would be
I can't hear you.
Be positive 2 and -1, right?
For our denominator? We want two numbers that multiply to be what? So here you would have -2. We want them to multiply to be 1, add to be 2. What should these be? Is +2 and -1 correct? Yes or no? It'd be +1 and what? Very good. It'd be +1 and +1. So x plus 1 times x plus 1. Now, we wanted to factor it so we could do what?
So you can set it to 0.
Set it equal to 0. So we have what?
X plus 1 equals 0.
Which means?
X equals -1.
Good. Do we need to write it again, although it appeared twice?
No, this is multiplicity.
No, because the multiplicity is 2. Very good, right? So x equals -1 is what?
X equals -1 is a vertical line. Vertical asymptote.
Good. Vertical asymptote. Use your words. Very good. X equals -1 is a vertical asymptote. Now I'm going to ask you what?
The domain.
Back row. Interval notation. Okay. I'll wait. Yes. Yes. What goes?
No, parentheses.
Oh,
-1,
good. Does anyone confirm it?
Yeah.
Yes?
Yes.
Okay. Confirmed.
Agreed.
Your domain and your vertical asymptote. What questions do you have? Okay, let's keep it moving. Let's keep it moving. Now we're going to talk about equations for horizontal asymptotes. Equations for horizontal asymptotes. Horizontal asymptote is in the form what?
Y equals.
Oh, it's in the form of y equals. Vertical asymptotes are in the form of?
Y
No. Vertical asymptotes are in the form of?
X
Equals C. Good. Horizontal asymptotes are in the form of? Y equals C. Good. Sound a little bit more enthusiastic. Horizontal asymptotes are in the form of?
Y equals C.
Vertical asymptotes are in the form of?
X equals C.
Vertical asymptotes are in the form of?
X equals C.
Horizontal asymptotes are in the form of?
Y equals C.
That's excellent. So now let's talk about equations for horizontal asymptotes and how to find them. How to find them is the thing. So suppose we start out with the rational function where P is an nth degree polynomial with leading coefficient a sub n, Q is an nth degree polynomial with leading coefficient b sub n, and P of x and Q of x have no common factors other than constants. Okay? Then, if n is less than m, the horizontal line y equals 0, the x-axis is the horizontal asymptote for f. If n equals m, the horizontal line y equals a sub n over b sub n is the horizontal asymptote for f. How many don't know what the heck this is saying? So let's write it out a little bit before we jump in with some examples. Suppose that we have, I'm going to use, so P is an nth degree polynomial with leading coefficient a sub n. This means P of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus everything out to a1x plus a naught. That's what it looks like. Okay? Then suppose Q of x is an nth degree polynomial with leading coefficient b sub n. So Q of x is equal to b sub m x to the m plus b sub m minus 1 x to the m minus 1 plus everything out to b1x plus b naught. Okay? So what? If you put P of x over Q of x, you have this polynomial of degree n divided by this polynomial of degree what?
Q. Oh, B.
M.
M.
Good. I heard Q, I heard B, I heard M. M is correct, right? Because it says it's an nth degree polynomial. Highest exponent for x. So now, if part 1 says, if n is less than m, so if you have n is less than this number, whatever it is, make sure you have it in descending order like this. That's important. If n is less than m, then the horizontal line y equals 0 is the horizontal asymptote. You're going to need to know this. If n is less than m, the horizontal line y equals 0 is the horizontal asymptote. If n equals m, so if these two are the same, then the horizontal line y equals a sub n over b sub n is the horizontal asymptote. So if n is equal to m, then you just take the leading coefficient over the leading coefficient. Y equals that will be your horizontal asymptote. Okay? If n is equal to m, then the horizontal line y equals a sub n over b sub n is the horizontal asymptote for your function. Okay? So, let's look at some examples. Find the equation for the horizontal asymptote of the following functions. F of x equals x squared minus 4 divided by negative x squared plus 2x. That looks a little small, so I'll zoom in. Is that all right?
Mm-hmm.
Okay. F of x equals x squared minus 4 over negative x squared plus 2x. Which case are we in, 1 or 2?
2.
Very good. We're in 2 because the degrees, variables of highest degrees, are the same. I'll stick with the same highlighter. So 2 and 2. Well, no, we use green, right? 2 and 2 are the same. So that means our horizontal asymptote is y equals what?
2 over 2.
What?
1 over negative 1.
1 over what?
Negative 1.
Negative 1. Good. We chose the what? It's a little tricky initially. We chose the leading coefficients of those,
Oh.
right? The leading coefficient. So you might want to ask yourself, what is the leading coefficient of the numerator? What's the leading coefficient of the numerator? 1, not the degree, but the leading coefficient. The degree is 2. The leading coefficient of the numerator is 1. What's the leading coefficient of the denominator?
Negative 1.
That's -1. Good. So y equals -1 over, or 1 over -1, which is what? -1. So all of that to say y equals -1 is your what?
Horizontal asymptote.
So horizontal asymptote. So if the degree of your numerator and the degree of your denominator are the same, then your horizontal asymptote is y equals the leading coefficient of your numerator over the leading coefficient of your denominator. If your numerator has degree less than your denominator, then what's your horizontal asymptote?
Y equals 9.
Y equals 0. Good. So let's talk about B. You have f of x equals x squared minus 81 over x cubed plus 7x minus 12. Which case are we in?
The first one.
We're in the first case, right? 2 is less than 3. 2 is less than 3. Okay? So, yes, we're in the first one. Since 2 is less than 3, we know what? What do we know?
We know the horizontal line.
We know the what?
The horizontal asymptote.
Oh, we know the horizontal asymptote
Oh.
is what? Y equals 0. Y equals 0. Very good. So y equals 0 is your horizontal asymptote. That's what we know. Okay? What questions do you have? So the only thing left in this section, oh, go ahead.
So is it always going to be 1 to 0?
Whenever the degree of your numerator is less than the degree of your denominator, your horizontal asymptote will always be y equals 0. When the degree of your denominator or degree of your numerator is less than the degree of your denominator, you will always have your horizontal asymptote is y equals 0. Yes. Say what?
The leading coefficient.
Talk a little louder.
The leading coefficient.
What about it?
What if it's less than
What less than what of the denominator?
the leading coefficient?
The leading coefficients, so the question is what happens if the leading coefficient of your numerator is less than the leading coefficient of your denominator? The leading coefficients do not tell us about our horizontal. It does not tell us whether we have a horizontal asymptote or not. The degrees of the numerator and the degree of the denominator tell us what we have about our horizontal asymptote. Yes, I see your hand, Ariana. I'm coming to you. Lisa, you had a question.
Yeah, I was going to ask what happens when the
Mm-hmm.
n is greater.
Right. So whenever your degree of your numerator, because that's a good observation, because I didn't put there the case what happens when n is greater than m. Remember, if you need to send a text message, go out in the hallway. When n is greater than m, when your degree of your numerator is greater than the degree of your denominator, you have what's called slant asymptotes. So meaning you can, so where you have a vertical, so this is an aside. Answer the question. If n is greater than m, then you have what's called slant asymptotes. because you can use polynomial long division or synthetic division to actually figure those out, but you won't do those in this class. Ariana, what was your question?
That was
The same question? Yeah. Good. What questions do you have? So now the thing is, you just put it all together and graph. Because now you have all the tools in your belt to graph. That's what chapter 6 ultimately leads up to. So, the next page. So on page 430 of your books, you have the step-by-step process for graphing rational functions. Now what we're going to do is we're going to go through that by sketching this graph. We're going to go through this process by sketching the graph of the following rational function. Okay? F of x is equal to x squared minus 4 over negative x squared plus 2x. What kind of function is this? We talked about them in this section. What kind of function is this? Section is all about what kind of function? Rational. This is a rational function, yes. Okay, so the first thing we want to do, we want to see if it's possible for us to simplify this, because that may give us some information. So the first thing we're going to do, we're going to factor our numerator as x plus 2 times x minus 2. And in our denominator, these two have what in common? An x? A positive or negative? I heard a positive, I heard a negative. Say what? A positive? We can factor out a positive. So if you have factor out a positive x, what are you left with?
X plus 2.
No.
Negative x plus 2.
Negative x plus 2. Good, both of you. Now, do these factors look like one of these?
Yeah.
Yes, no? I see no. They don't look identical, right?
They could, though.
How so?
factor.
Factor out a negative, right? Factor out a negative, and then one of the factors will look the same. So here, factor out a negative 1. So this will become x plus 2 times x minus 2. Now we're factoring out a negative 1, so this is now negative x. What are you left with?
X minus 2.
X minus 2. Now, do they have anything in common? Yes or no?
Yes.
Yes, what is it?
X minus 2.
X minus 2, right? So now we cancel out these factors, x minus 2, and we'll say what that does to the graph. So canceling, this is just a rule of thumb. Make sure you remember it. Canceling common factors. Canceling common factors gives a hole in the graph. A hole. We can spell hole. Gives a hole in the graph. So where we canceled x minus 2, so this means x minus 2 equals 0 or x equals 2. So there will be a hole at x equals 2. Whatever y is, the corresponding y, that's what we're going to have. So this function simplifies to be x plus 2 over negative x. Okay? And that's the first thing that we do. So then what we want to do is we want to find the zeros. Do you want to, we are 1 minute over. Do you want to take a minute and finish this?
Yeah.
Or do you want me to finish recording it and call it a day?
Is the next one the same thing?
The next one, remember, we're not doing polynomial inequalities.
I think we should just finish it.
So let's just finish it, okay? So we found that, okay? So now your step, now what you want to do is you want to, I'll put bullets for our steps. Now we want to find the zeros, I'm being very specific, the zeros of the numerator. We're finding the zeros of your numerator. What's the zeros of the numerator?
X minus 2.
X. Say what? X equals negative 2. Good. Because you have x plus 2 equals 0. So x equals negative 2. But this is not a vertical asymptote because we're looking at our numerator, right? That's just an observation. So now we need to find the zeros of the denominator. And what's the zeros of the denominator? So specifically, we're going to find our vertical asymptotes. That's what this step is doing. So what do we have to do with our denominator? Good. Set it equal to 0. So you have negative x equals 0, which means x equals 0. X equals 0 is the vertical asymptote. You got it. So if you want to, I tend to like to put my graph together as I'm going along instead of waiting till the end. Remember, x equals 0 corresponds to the y-axis. So that's x equals 0. We know that's a vertical asymptote. And so now the next step is you have your vertical asymptote at x equals 0. We've graphed that. And so now we want to find our horizontal asymptote. We know f of x is equal to x plus 2 over negative x. How do we find our horizontal asymptote? That's right. Good, both of you. And we went to that because the degrees are what? The same. So the degrees, so let's write the observation. The degrees of the numerator and denominator are the same. So that means we're in case 1 from my page before, right? So y equals 1 over negative 1, which is negative 1. So we take our coefficients, and that's what we did here, which means y equals negative 1 is a horizontal asymptote. So you can go ahead and put your horizontal asymptote at y equals negative 1. And we label it. So we label it there. And then you find your y-intercept if there's one. So you find your y-intercept if there is one. Y-intercept, we set what equal to 0?
X.
Good. So we're finding f of 0. But remember, that's, come on, highlight. That's f of x. So f of 0 is equal to 0 plus 2 over negative 0, which we cannot do, right?
Yeah.
0 plus 2 over negative 0, which means it is undefined because we cannot divide by 0. So we don't have a y-intercept. And so then what we do is we put our numbers from this step and this step on a number line, and we test points. So then put values from first 2 bullets on a number line and test points. because you want to see if your graph, if it's going to be positive or negative, so you know whether the graph is above or below. Okay, so here we're going to put -2. The other one is 0, right? So whenever you're to the left of -2, to the left of -2, you can choose a -3. You can test -3. If you want, different color means we're just testing. So -3. So f of -3 would be -3. So f of -3 is -3 plus 2 over negative times -3. All we care about is if it's going to be positive or negative. This is going to be a negative. So that's what we get there. A number between -2 and 0, -1. F of -1. F of -1, if you put in -1, you're going to get -1 plus 2 over negative times -1. Is that going to be a positive or negative? I heard positive. It's a positive, right? Good. It's a positive. So this part is positive. This part is negative. And then we can check a number to the right. Check 5, and we're going to get what kind of number? Negative, because you have f of 5 is 5 plus 2 over -5. So you get a negative here. You get a negative on this part. So what does that tell us? That tells us that to the left of -2, we know that to the left of -2, so we go up here on our graph, that's -2. To the left of -2, we know our graph is below the x-axis, and then it's above. Does that make sense? It's above, it's below to the left because this is negative, above to the right, between because this part was positive, and we know it doesn't touch, it being our graph does not touch the horizontal or vertical asymptote. And then we know to the right of 0, our graph was what? Negative, so we expect it to be below, right? But remember, we have a hole where? 2. So wherever we're graphing, about there, we have a hole. And that's it. That's 6.5. That concludes chapter 6. Thank you all for sticking around for it.
Miss, I have a question.
Yeah, go.
About the review set,
Yes.
I couldn't really see anything about it. Like,
Which
is it supposed to be how it normally